Well, welcome everyone. My name is Scott Suhita. I'm here from Altair. So before I start off, I want to just ask, who knows Altair? You know Altair? Okay, good. I got one. Who knows PBS? Who's heard of PBS? Oh my goodness. All right. So this is actually good then. All right. So what I'm going to talk about is what we focus on is the technology so that you can work on what really matters to you. So I'm going to do a quick introduction to the technology, and then I'm going to talk about how we have applied it at one of the universities. So Altair, we are a software global technology company. We have a lot of different software solutions in simulation, data intelligence, and cloud computing. So we've got design, modeling, and visualization, and physics simulation, which is something that I'm going to be talking about in our application here, and our high-performance cloud computing. Altair actually offers a wide variety. It's the broadest portfolio of optimization-enabled solvers. So we have things for systems, manufacturing, electromagnetics, structures, crash and impact, thermal, and fluid dynamics. I wanted to have this slide here because this actually takes a very complex system, the car, and all of our solvers here are applied to this vehicle. If it's from Radios, which is doing crash and safety analysis, to OptiStruct, which is doing durability, vibration, acoustics, and you can see these waves coming off the vehicle here. This is CFD. This little blob over here, what that blob is doing there, that's the electromagnetics from the antenna. So we can simulate all of these things at one time with our solvers. Now this problem here is really, really big. So what are we going to need, where are we going to need to run all these solvers on big systems here? So this is where the other part of our company comes into play with PBS Works. PBS Works makes it easy to manage HPC clusters, cloud, and supercomputing environments. So this is where we talk about, let's see, it's on here. PBS Professional, the one right here in the middle, is our workhorse that determines the when and the where, the scheduler. We have Altair Access, which is a portal for our users and our scientists. So all they have to do is open up the portal, click on what they want to run, and it does all the magic behind. On the other side, on your right side here, Altair Control is focused on our administrators. Our administrators then can set up the systems and make it so that we can run on-premise or in the cloud. All right, so for PBS Professional, we got a ton of scheduling policies. Now, all of this is building up to what we did with the university. We got a ton of scheduling policies. We make sure that we're optimizing for their utilization of the system. For performance, we are really, really fast at scheduling. And even with multiple types of scheduling policies. Resiliency, we make sure that there's no one point of failure here. Open architecture, we have this plugin framework that allows administrators to integrate with other third parties. So say for instance you are doing something with Cray Data Warp or NVIDIA and you want to integrate that into scheduling, you can do that. All right, so all this technology comes together so that in the Catalyst UK program, have you heard of the Catalyst UK program? Wow, where is everyone from? That's like the biggest thing that HPE, SUSE, ARM, and Marvel have been talking about this week. All right, so the mission was to accelerate the adoption of supercomputing applications in the UK, really focusing on the ARM software ecosystem. So we were working with SUSE, we were working with ARM, working with a number of them, HPE, ARM, SUSE, and Marvel, and our academic universities. And they've been in production for 9 months right now, running PBS Professional, ARM, and such. Simon Burbage, who actually manages the University of Bristol facility, said, PBS Professional just works. That's like the best quote we could get from him. So, Radios, here's some fun animations. This kind of gives you an idea now of what Radios is doing. Radios is taking care of crash worthiness. We're doing airbag deployment on the side. We've got physical on the right side, simulation modeling on the left side. This is where you can do your digital twin. We can do contact where we're dropping a cell phone, and for some reason my plane is not landing. But this is where you're going to ditch it, and you're going to try to see how this plane will actually land safely in the water. This particular model is what we ran. This is a public benchmark. We ran it on the University of Bristol system. It's a 10 million model element. And you can see we got airbags going off, we got crashing. You see the mechanics of the wheels are still spinning in this crash. We benchmarked it. We started benchmarking on the number of nodes, 1 node all the way up to 48 nodes. 48 nodes gave us close to 3,200 cores. So this is the commercial application doing this crash analysis, 3,200 cores. You can see time to solution dramatically decreased here. At 3,200 cores, this blue line is a good representation of an Intel Xeon processor that you can buy off the shelf today. You can see that our performance slightly better. This is good. This right now is we're waiting for the SVE extension to be exposed, because then we're expecting it to be even faster time to resolution. So I want to highlight another thing here is, so we're the first commercial structural code to be ported to ARM. And because we ran this on SUSE in the University of Bristol, this is actually a pretty big milestone. Performance was really good. It was better than we were expecting. And with the SVE extension, we're expecting it to be better, even more improved. So that was my presentation. Do we have any questions? You came in a little late, so that's okay. Yes?
So you're using ARM over Intel because that's better still?
So this comes back to the program at the Catalyst UK. We're working with them to help them adopt ARM software in their environment. So they asked us, because we're commercial, because a lot of open source is already being ported to ARM. They asked us because we're commercial and they use it, so we did that exercise. So now they're looking at it and saying the power to performance ratio is really, really good, so that this is a benefit. And the performance that we got already is good.
And so the reason they want to do an ARM ecosystem is for the performance to power?
That's what they're looking at, yeah. They want to help grow that ecosystem. Yes? Any other questions?
Will you be around for a minute if they want to?
Absolutely, yes,
right.
yes.
Sounds good. Let's give them a big hand. Thank you, Altair.
Thank you, everyone.
For coming to our booth.